Hi, I'm Adolph Oliver, and the current lesson is about lowest common multiples. Now, if it turns out that the numbers we're talking about are denominators and fractions, then we talk about lowest common denominator, or LCD. So this method of finding the LCM, or lowest common multiple, is exactly the same thing we use when we want to find an LCD when we're adding or subtracting fractions. Now, there are two main methods that are used here. Many of you are used to figuring out LCDs in your head, and when you're doing that, you're actually using some version of what I'm going to call here the multiples method. Let's give an example of how the multiples method works. Let's say that we're just working with regular numbers here. There are no fractions involved, so we'll talk about finding the LCM of 6 and 8. Okay, well, what you do is you make yourself a list of the multiples of both of these guys. The multiples of 6 and the multiples of 8. Well, the first multiple of 6 is 6. Add 6 to that, the next one is going to be 12. Add 6 to that, we get 18, and then you go out to 24 and 30 and 36, and of course these multiples go on. Well, we can do the same thing for 8. The first multiple of 8 is 8, the second is 16, then we have 24, then 32, and then 40, and of course they keep going on. Well, if you extended these multiple lists out, every so often you'd find numbers that they both hit. Well, what we want is the first one, the lowest one that's common to both, and we see right here that it's 24. So, what would the LCM be of 6 and 8? It would be 24. Now, let's talk for a moment how this would work if these guys happen to be fractions, for instance. Let's say we had 5 6 plus 3 8 that we wanted to add. Well, of course, we don't have a common denominator, so we've got to figure out what the LCD is. Now, one of the things, of course, you can always find a common denominator simply by multiplying the denominators together. 6 times 8 would be 48, but that often gives you something which is higher than what you need. Now, in regular basic math, where you have all the numbers like this, that makes the problem harder. You're dealing with larger numbers, but if you don't make any mistakes, you'll still get the correct answer. But when we get further along in the algebra, where we start having x's and y's down here in the denominators, you want to make sure that you have the lowest common denominator, because anything higher gets to be extremely messy, and it makes it much more difficult to get the answer correct. So finding the LCD becomes more and more critical, especially as you move along in the algebra. Now, instead of going through all of this in your head, what you do is the equivalent method, and let's point this out to you. It's still using the multiples, and that is we turn around and look at the two denominators and take the larger one. Now, the reason we work with the larger one is very simple. We get the answer sooner. That's a very good reason to do it. Think of the multiples of 8. The first multiple of 8 is 8. Does 6 divide evenly into 8? No. The second multiple of 8 is 16. Does 6 divide into 16? No. The next multiple of 8 after 16 would be 24. Does 6 divide evenly into 24? Yes. So, what we find out then, just by doing that in our heads, and this is LCD now since these are denominators, the LCD equals 24. Now, of course, that's the same thing we got up here, and the process is similar, only what you're doing here is you're just concentrating on the multiples of the larger guy, and the first one that the other guy divides into evenly, that's the LCD. So this is a multiples method, and very common to what you guys do when you figure out an LCD in your head. But now, let's take a look at something that's a little bit messier. This next problem is not super bad. If you thought very clearly about this, you could use the multiples method to figure out what the LCM is of 16 and 18. But these numbers are getting pretty big to work multiples out on. So what I'm going to do is show you the prime factors method. Okay, and this involves taking and prime factoring the numbers that we're dealing with. So here I'm going to list the 16 and the 18, but now what I'm going to do is indicate what their prime factors are. Well, you could use the factor tree on this, but if the numbers are simple enough, you can often figure out what the primes are in your head. Let's try that. For instance, 16 is 4 times 4. Well, you know each of those 4s is 2 squared. So if you have a couple of 2's in the first 4 and you have a couple of 2's in the second one, that's a total of 4 2's that you have. So it is indeed true that 16 is 2 to the 4th. Now, you, of course, can use the factor tree on this if you want. But if you multiplied 4 2's together, 2 times 2 is 4, times 2 is 8, times 2 is 16, you'll see that 2 to the 4th is indeed 16. So any way you can come up with the primes here, which multiply back together to give you the original guy, guess what? That's the correct answer. Now, for 18 down here, we know 18 is 2 times 9, and 9, of course, is 3 squared. So we can write the prime factorization of this as 2 times 3 squared. Well, 3 squared is 9, 2 times 9 is 18. Since these guys are all primes, that has to be correct. Now, the question is, how do you come up with what the LCD is? Well, you now do this process, and I'm going to call it, of course, the LCM here because these are not from fractions, but if they were, it would be LCD. The process is exactly the same. Here's what you do. Go back and write all the different base numbers you see. The base numbers are the regular numbers. The little guys, of course, are the exponents. Now, we see 2 as a base and we see 3 as a base. If the base shows up more than once, you only put it in your list once. Doesn't matter how many times it shows. If you see it once, you put it in. If you see it more, you still put it only in once. So I see 2, I put that in my list. Now, I also see 3, so I put that in my list. Okay, these are the base numbers. Now, we go back and take the highest power we see for each of these. Okay, for instance, remember, of course, this 2 down here with the 18 is 2 to the first power. So when we look at the 2's, I see a power of 4 here and a power of 1 here. Well, 4 is the higher, so I use 2 to the 4th in my answer down here. Now, likewise, I turn around and take a look, and I've got 3 squared here. Well, that's the only 3 that I have, so it is the highest power, so 3 squared. Well, this is the LCM, or LCD, right here. All we have to do is put it back together. 2 to the 4th is 16, times 3 squared is 9. What's the LCD or LCM of this? Well, 6 times 9 is 54, carry the 5. 1 times 9 is 9 plus 5. 144 is the lowest common multiple for these guys, and we found it by the prime factors method. This one would have been fairly hard to keep track of multiples up to 144 in your mind. When you have simpler numbers like we had in this last example, it's not difficult to think about the multiples in your head and figure out what it is. But when they get to be more involved rather quickly, the best way to go is to use this prime factor method. Okay, well, we're going to make use of both the multiples method and the prime factor method as we look at some examples. So let's get going on this. And the first one, right here, find the LCM of 9 and 15. Okay, well, yeah, I think we can do this with multiples in our head. Remember, start with the larger number simply because you get the answer quicker. The first multiple of 15 is 15. Does 9 divide evenly into 15? No. The next multiple of 15 would be 30. Does 9 divide evenly into 30? No. The next multiple of 15 after 30 would be 45. Does 9 divide evenly into 45? Well, I think it does. 9 times 5 is 45, isn't it? So we get from this that the LCM here, okay, equals 45. That's the first multiple of 15 that 9 would divide into. So this one's still easy enough that we can go ahead and use the multiples method. Well, here's another example, and this one actually even a bit easier than the last one. 6 and 15, we want to find the LCM here. Well, again, the numbers are easy enough that we can do it in our head. The first multiple of 15 is 15. Does 6 divide evenly into 15? No. The next multiple of 15 is 30. Does 6 divide evenly into 30? Yes, it does. So in this case, the LCM equals 30. Okay, well, the multiples method doesn't work too bad if the numbers are fairly simple, but here it's going to be a little bit more difficult to keep track of the multiples in your head. You could do this, but at this stage you're getting to the point where it's time to start making use of the prime factors method, and that's exactly what I'm going to do here. I'm going to write down 40 equals and 50 equals. Now 40 is 5 times 8, and 8 is made out of 2's, a total of 3 2's multiplied together. 2 times 2 times 2 is 8, and so 8 times 5 would mean I've got 2 cubed and 1 5. Now let's double check this. Remember, if the numbers are simple enough, you can often figure out what the prime factorization is in your head. If you're not sure about it, go ahead and use the factor tree. But if I had a total of 3 2's here, 2 times 2 would be 4, times 2 would be 8, so 2 to the third is 8. 8 times 5 is 40, that's correct. Now 50, I think, is even more easier because 50 is just 2 times 25, and 25, of course, is 5 squared. So the prime factorization of 50, 2 times 5 squared. This would be 2 times 25, so we know it's correct. Okay, how do we turn around now and come up with the LCM on this? Remember, you write down all the different bases you see. If they show up once, you put them in the list. If they show up more than once, you still just put them in the list once. So we see 2's and we see 5's. Okay, go back and take the highest power that you see for each of the bases. For the 2, there's a 1 here and a 3 here. 3 is the highest power. For the 5, there's a 1 here and a 2 here, so 2 is the highest power. Okay, put this number back together. It's going to be what your LCM is. 2 to the third we know is 8. 5 squared we know is 25. Well, 8 times 25 is going to be 200. So 200 in this case is our LCM. Okay, well, 12 and 14 aren't too bad. You could probably do this in your head, but once you get this prime factors method down, it's easy to do. Let's use it. 12 equals 4 times 3, and 4, of course, is 2 squared. So here is our 4 times 3 giving 12, and that's the prime factorization. 14, on the other hand, is just 2 times 7. Those are both primes, so there's the prime factorization of 14. Okay, remember what we do? To find the LCM, we just first take all the different bases we see. We see 2's, 3's, and 7's. Remember, you only put them in the list once, even if they show up more than once. Okay, go back and take the highest power that you see for each. Well, 2, the power is 1 here and 2 there, so the highest power for 2 is squared. Both 3 and 7 are both to the first power. So here it is. Now just put it back together. Okay, 2 squared, of course, is 4, so I've got 4 times 3 times 7. Well, okay, let's multiply this number all the way out. 4 times 3 is 12, and 12 times 7 is going to give me 84. So there is the LCM for 12 and 14 by the prime factors method. Now, something like 36 and 48, definitely here use the prime factors method. It'd be difficult to keep track of this in your head. So here we go once again. 36 equals and 48 equals. Now, 36, of course, is 4 times 9. And 4 is made out of a couple of 2's, and 9 is made out of a couple of 3's. So the 4 would give me 2 squared, and the 9 would give me 3 squared. Well, double check this. 2 squared is 4, 3 squared is 9, 4 times 9 is 36. That's correct. Okay, what are we going to do with 48 here? Well, let's see. 48, we could take 6 times 8. 6 has got a single 2 and a single 3, and 8 has got 3 3's. Well, let's see. We've got a single 2 from the 6. We've got 3 2's from the 8. So that should be 2 to the 4th. And then we had that 1 3 left over from the 6, which was 2 times 3. Let's double check this to make sure we're right. What's 2 to the 4th? Well, if we had a total of 4 2's here, 2 times 2 would be 4, times 2 is 8, times the last 2 is 16. What's 16 times 3? That is indeed 48. Now, again, if you had a little difficulty working somebody like this out, just use the factor tree on them and you'll get the correct factorization. Okay, once you've got these guys prime factored by whatever method you used, now we can find the LCM easily. Okay, go back and take all the different bases you see. I see 2's and 3's. You only put them down once in the final list. But now remember, you have to go back and take the highest power that you see for each of these. Well, for the 2, I see the power 4 and the power 2. 4 wins, so this is 2 to the 4th. Over here for 3, I see 3 squared as being the highest, so I have 3 squared here. Okay, let's put this back together and figure out what we have. 2 to the 4th is 16. 3 squared is 9. Okay, multiply these guys together. 6 times 9 is 54. Carry the 5. 1 times 9 is 9, plus 5 is 14. There's our LCM for these for 36 and 48. It happens to be 144. Now, there's no reason, of course, that you can't have more than 2 numbers that you're working with. It's not uncommon that you have 3 or more fractions that you're multiplying, and you have to figure out what the LCD is for all of them. Well, here we go. Again, we got more than 2 numbers here. You could do the multiples method. You'd have to think of the multiples of 12, and both of these guys would have to divide evenly into it. But when you got 3 like this, it's getting messy enough that it's good to use the prime factors method again, so let's do that. 12 and 10 and 4. These guys are not difficult to come up with the prime factors. 12 is 4 times 3. 4 we know is 2 squared, so 2 squared times 3. 10 is 2 times 5. That's the prime factorization of 10. And, of course, 4 is just 2 squared. So it was pretty easy to come up with the prime factorizations here. So if that's not difficult, you get the LCM real fast. What are the different bases I see? I see 2's, 3's, and 5's. So I put them in my list. Here it is. Now I have to go back and take the highest power that I see for any of them. For the 2's, the highest power is squared. And for the 3 and 5, they're both to the first power. Okay, well, just put the number together. This is going to be what our LCM equals. 2 squared is 4 times 3 times 5. Well, 4 times 3 is 12. 12 times 5 60 is the LCM for 12, 10, and 4. Okay, one last example, but I think you're beginning to see that this prime factors method works nice here. And once you've got the prime factors of the numbers, it's very easy to come up with what the LCM is. And we're going to be using this prime factors method in the algebra when we start dealing with all the x's and y's. Okay, well, let's again list all the numbers. I got 12, 16, and 20. We've got 3 of them here. This would be the easiest to work it out with the prime factors method. Again, 12 is 4 times 3, and we know 4 is 2 squared, so the prime factorization of 12, 2 squared times 3. 16 is just made out of 2's, a total of 4 of them, 2 to the 4th. 20 is 4 times 5. Well, 4 is 2 squared times 5. Okay, there's the prime factorization. Now let's put together what the LCM equals. Once again, take all the different bases. I see 2's, I see 3's, I see 5's. So 2 times 3 times 5. Now go back and take the highest power you see for each of these bases. For 2, the highest power is 4. The 3 and the 5 are both to the first power. So here it is. Let's just put it together. 2 to the 4th is 16, and the 3 and the 5 remain the way they are. Okay, well, what does this multiply to? 16 times 3 is 48. Let's just put that down here. This is 48. So we have to take 48 times 5. Well, 5 times 8 is 40. Carry the 4. 4 times 5 is 20, and 4 makes 24. So here we go. What is the LCM for 12, 16, and 20? The first and lowest common multiple it hits is 240.